Scientists are issuing urgent, unmistakable warnings tonight. Across America's volcanic landscape, tremors, gas emissions, and seismic signatures are stirring a wave of unease. Not in one isolated region, this is a broader phenomenon.
Of a U.S. volcano eruption after a 4.6 earthquake hits in the Pacific. I'm going to give you the latest updates. This is coming out in the last 24 hours.
At 5 of the most closely monitored volcanoes, the latest observations point to a sudden escalation in volcanic activity, commanding the attention of both experts and communities alike. The sheer scale and rapidity of these developments are striking even for veteran geologists. Laboratories, emergency management centers, and observatories are on heightened alert, a chorus of urgency and caution. As the reality of elevated volcanic risk sets in, officials and citizens alike are reminded of how quickly stability can yield to upheaval. You can feel it, a collective tension settling over communities, research teams, and disaster officials. Thoughts race. What exactly do these intensified volcanic signals mean for those living near the nation's most watched peaks? When warnings don't emerge in isolation, but come in clusters, the stakes multiply. The risk is no longer theoretical. Hazard alerts have risen, local authorities are on standby, and scientists work in shifts to monitor shaking ground, shifting gas levels, and changes deep below the Earth. This is no ordinary episode. This is not an exercise, not a customary drill. It is an unmistakable signal that the planet's dynamic nature can, at times, shift rapidly. The current unrest is more than the usual background noise. It is a sustained crescendo, supported by mounting data and real events. And it may very well force a re-evaluation of established hazard forecasts and safety zones. The question pressing on every mind, with 5 U.S. volcanoes now showing pronounced signs of activity, could we be witnessing a shift in the nation's volcanic risk landscape? But the awakening here is only part of a global story. Around the world, 5 volcanoes have erupted within just 72 hours, a vivid demonstration of Earth's ongoing geologic processes and a reminder of nature's tremendous force. America's volcanoes now appear to be joining that renewed rhythm. For scientists, it's a call to urgent action. Analyze every instrument reading, revisit every pattern, question every assumption. If multiple dangerous volcanoes across the United States are becoming restless together, is this simple coincidence or a sign of a broader, underlying process at work? What could drive simultaneous volcanic unrest across such distance? According to Dr. Langston Redford, senior geophysicist at the Pacific Seismic Observatory, this phenomenon may be tied to the Earth's dynamic interior. He explains, multiple volcanoes can become active in a relatively short time window if there are regional or global shifts in factors like magma migration or tectonic stress. Whether these warnings lead to full eruptions is not yet clear, but the signals are concerning. Seismic activity is being monitored not just at the surface, but throughout the planet's hidden reaches. Data collected in the last several days indicate magma on the move, deep, forceful, enough to fracture rock, generate new earthquakes, and heat water tables near the surface. Dr. Redford now speaks of escalating risk thresholds, a technical term that marks the shift from probability to increased possibility. Before we detail the signs and magnitude of each awakening giant, hit that subscribe button now. Join our channel to stay informed on seismic events, scientific advances, and alert systems you can trust. Preparedness has never mattered more. Within the span of a few minutes, barely long enough to brew a cup of coffee, America's most closely watched volcanoes have prompted scientists to heighten alert levels. The core of this crisis is a rapid sequence of subtle, then clearly anomalous geophysical signals. Tremors rattle the ground, uplift and deformation are measured, and the steady rise of heat and gas from geological vents signal renewed activity. At Axial Seamount, the undersea volcano, located roughly 300 miles off Oregon's coast, scientists have detected a significant uptick in seismic tremors. These are characterized by patterns called harmonic tremor, widely understood as evidence of magma movement. Autonomous seafloor sensors have registered sequences of low-frequency earthquakes, the energy rising noticeably. To volcanologists, these signals all indicate that molten rock is mobilizing. The intensity and frequency of these tremors are higher than we've seen in recent years, observes Dr. Emily Yamaguchi, lead volcanologist at Oregon State's Marine Hazard Institute. While this does not guarantee an eruption, it is a clear precursor that demands careful attention and ongoing monitoring. On land, similar unrest is being closely followed at 4 major volcanic centers in the western United States. At Yellowstone, renowned for its supervolcanic history, ground deformation maps show areas of noticeable uplift. Satellite data confirms centimeters of movement in the Earth's surface over just days. Sensor arrays have picked up clustered, shallow earthquakes beneath the Norris Geyser Basin, a pattern recognized as a potential warning sign. While these signals have sometimes been treated as typical background activity, experts are now focused on their increasing number, severity, and simultaneous occurrence. It's the combination and acceleration of these indicators that is unusual, explains Dr. Redford. When multiple signals, uplift, earthquakes, gas emissions, intensify at several locations in parallel, we pay very close attention. Mount Rainier, typically tranquil under its cloak of glaciers, is now reporting higher than normal sulfur dioxide emissions. This rise in volcanic gas can indicate that magma is approaching the surface and may become mobile enough to cause further unrest. Geochemical monitoring teams are on alert, advising local authorities and updating community response plans as a precaution. In California's Long Valley caldera, as well as at Hawaii's Kilauea, a pattern of persistent, low-frequency earthquakes has emerged. New fissures emit steam, and seismic noise has risen to the level that prompts additional scrutiny from volcano observatories. These patterns, while not unprecedented, are being watched for further escalation. If these signals were scattered in time or space, scientists might consider them coincidental. However, their close timing and common characteristics create a complex puzzle, one that could challenge existing models of volcanic hazard. The underlying question persists. What, if anything, has prompted these 5 volcanoes to stir in apparent unison? To explore this unusual spread of volcanic activity, scientists turn to the fundamental forces that drive our planet. Far beneath the crust, in the high-temperature region known as the mantle, convection currents rise and fall, a process that continually reshapes continents, lifts mountain ranges, and can supply local reservoirs of magma. Using a combination of geophysical sensors, seismologists now monitor a potential increase in mantle convection, particularly beneath the Pacific Northwest and western United States. Elevated mantle plumes, or hotspots, geological features known for transporting heat and melt from the deep earth to the surface, may be contributing to the present unrest. While the specifics are still being analyzed, changes in mantle dynamics can redistribute stress across large sections of Earth's crust. This shift may cause magmatic systems to pressurize and create the types of seismic and gas emissions now being recorded. We're tracking gravity anomalies, subtle changes in the Earth's gravity field that can signal movement of magma or shifts in mass, says Dr. Natalia Franco, planetary geophysicist at the USGS Eruption Response Group. Recent data show patterns consistent with increased mantle flow beneath some of these volcanoes. Above ground, atmospheric forces can add another layer of complexity. Heavy precipitation, rapid snowmelt, or abrupt weather changes may destabilize already pressurized volcanic systems. These interactions are closely watched, but their precise influence on eruptive cycles remains a matter of ongoing research. Satellite imagery also points to expanding zones of surface heating at multiple volcanic locations, a sign that magmatic or hydrothermal activity may be increasing beneath. Within the past 72 hours, 5 volcanoes elsewhere in the world have erupted, adding to the sense of a planet-wide shift in geologic energy. While this international pattern isn't conclusive evidence of direct connection, The coincidence has prompted new questions and additional vigilance among researchers. Ground deformation, seismic swarms, gas emissions, all are tracked in real time. The challenge is to determine whether these signals will subside or escalate to eruption. What confronts scientists is not just the possibility of individual unrest, but the more complex risk of sequential or interacting hazards, a cluster of events that could test the nation's scientific and emergency response capabilities. How do scientists recognize the prelude to eruption? The modern volcanologist relies on a suite of sophisticated tools: seismic networks, gas analyzers, satellite data, and ground-based monitoring to decode nature's subtle warnings. At Kilauea on Hawaii's Big Island, the latest signs include swarms of moderate earthquakes within Kaluapele, the summit caldera. These quakes have clustered near the well-known Halema'uma'u crater, noted for its frequent activity in recent years. Accompanying the quakes, observers have spotted new steam vents and sulfurous gas emissions, classic signals of expanding volcanic unrest. Nighttime illumination has revealed glowing clouds within the crater, a stark sign for local residents and officials.
Beneath Oregon's coastal waters, Axial Seamount's sensor network has welcomed corresponding signs: increased hydrothermal venting, short spikes in seafloor water temperature, elevated methane emissions, and fresh fissures recorded by remotely operated vehicles. Such indicators often precede underwater volcanic events, though rarely with perfect predictability. Yellowstone's famed geysers are now joining the activity with fresh steam vents, slight changes in geyser rhythm, and new areas closed to visitors due to unstable ground. We track changes in gas chemistry, especially carbon dioxide and sulfur emissions, notes Dr. Anna Yates, Yellowstone's chief geothermal scientist. Recent readings are above average and have triggered expanded monitoring. Long Valley Caldera adds its own signals. Satellite interferometry has revealed new undulations in the land, breathing movements that reflect pressure changes below. These can precede minor eruptive episodes or simply indicate fluctuation in an established geothermal field. Small earthquake clusters are being tracked closely for signs of expansion. Mount Rainier continues to exhibit anomalous melting along its glaciers and increased gas emissions along well-studied volcanic cracks. River temperatures at nearby streams have risen slightly, prompting further testing of glacial runoff and volcanic gas migration. These combined signals, earthquakes, gas, heat, surface changes, are well documented in the scientific literature as precursors to eruption. Importantly, while individual signals can sometimes be dismissed, their concurrent rise across several volcanoes is noteworthy and suggests larger-scale processes at work. Dr. Redford summarizes, "There is legitimate cause for concern. We are seeing multiple indicators, not just at one volcano, but several. This ups the ante for preparedness and monitoring, though it does not guarantee eruption in any specific timetable." The accumulating evidence has spurred renewed outreach to officials, local planners, and the public. Scientists and emergency responders are careful to balance caution with calm, continuing to track developments alongside historical records and updated models. If the signals proceed to eruption at even one of these sites, what consequences could follow? And might activity at one volcano influence unrest at another? Increased volcanic risk comes with a range of hazards, many of which begin before any visible eruption. History is filled with examples of communities impacted by ashfall, noxious gases, and fast-moving debris long before the television cameras ever arrive. Consider Mount Rainier, known for its extensive glaciers. Volcanic heating could trigger lahars, slurries of mud, ice, and volcanic debris that travel far and fast. These flows are among the region's greatest hazards. Rapid glacier melt during volcanic unrest can have knock-on effects for downstream communities, says Dr. James Kohler, USGS Emergency Hazards Coordinator. Being ready for sudden evacuations and river flooding is key. At the Long Valley caldera, a moderate eruption, or even ongoing seismic swarms, volcanic winter, a dramatic drop in global temperature due to extensive ash in the atmosphere, is typically reserved for larger eruptions and, while possible, is not considered imminent at this time. For Kilauea and axial seamount, the hazards expand. Undersea eruptions could generate localized tsunamis or marine ecosystem changes caused by shifts in ocean chemistry. While the risk to widespread populations is usually limited, coastal areas and those reliant on ocean resources may be impacted.
At Yellowstone, the well-studied volcanic system has the potential, in an extreme scenario, to produce widespread ashfall over multiple states. Even smaller episodes could briefly disrupt transportation, power, and agriculture. However, it is important to emphasize that current signals, while noteworthy, remain within historical norms for periods of increased activity. In the wake of the latest alert levels, emergency management agencies have revisited existing evacuation plans and conducted multi-agency drills. Schools, hospitals, and transport providers are updating their protocols, even as scientists stress that these are standard preparedness measures, not evidence of imminent disaster. Invisible threats, like odorless gas clouds, ground destabilization, and altered water chemistry, are also being tracked. Slow heating of the ground, water table changes, and gas migration can all cause secondary hazards, notes Dr. Natalia Franco. Close coordination with local water authorities, utility providers, and healthcare systems remains a priority. The goal of all these activities is simple: ensure that public awareness, scientific vigilance, and community readiness are aligned as closely as possible with the evolving risk, however uncertain its timing and nature. As attention mounts with each new eruption warning, researchers are asking whether simultaneous clusters of volcanic activity are linked or simply reflect random coincidence in a restless planet. To explore this, Earth scientists apply the concept of compound hazard events, scenarios in which separate but rare occurrences overlap in space and time. We don't claim definitive causality, but we do see patterns, says Dr. Sophie Antonelli of the International Observatory for Geodynamic Change. An uptick in global volcanic activity, including major events in Ethiopia and the Pacific Ring of Fire within the same 3-day period, warrants deeper investigation. Seismic, satellite, and gravity data are now being analyzed for broader trends. Minor shifts in the Earth's magnetic and gravity fields, as well as global patterns in earthquake activity, are being used to refine forecasts and update risk models. While volcanologists are cautious not to overstate connections without clear evidence, heightened awareness and monitoring across global networks are prudent responses in times of increased activity. Atmospheric factors, such as changes in jet stream patterns, surface pressure, and precipitation, are also monitored for potential secondary effects. Rapid swings may contribute to surface instability and affect how volcanic gases are transported or dispersed. Dr. Antonelli cautions, science is still unraveling the triggers behind synchronized volcanic unrest. We do know that Earth systems are interconnected, and compound events, while rare, can happen. The combination of domestic and global volcanic events in such quick succession is unusual, but within the planet's geologic history, not unprecedented. Scientists emphasize the need for vigilance rather than alarm, focusing on precise measurements and communication rather than speculation. As sensors continue picking up the restless energy beneath these volcanoes, a familiar question confronts communities and leaders. Are we prepared for the possible impacts of volcanic unrest? Recent surveys and emergency response exercises reveal both strengths and gaps. While many regions have updated evacuation maps, warning systems, and public information campaigns, some communities remain less informed about volcanic hazards, especially those living beyond established danger zones. For residents in the shadow of these mountains, the response is a mix of concern, practical action, and steady determination.
Text alerts ping across phones. Emergency supplies are checked, and families discuss plans for what to do if an eruption warning escalates. Scientists like Dr. Anna Yates emphasize preparedness and open communication. We have good tools, real-time sensors, public alerts, constant data review. But volcanoes retain an element of unpredictability. Our job is to recognize trends, communicate risk, and avoid either alarmism or complacency. Across the region, responders review checklists, shelters, evacuation routes, special provisions for vulnerable populations. School districts practice closure drills, while critical facilities develop backup plans for power and water. Despite the uncertainties, a quiet resilience persists. The country has weathered eruptions before, most recently the 2018 Kilauea eruption, and, decades ago, Mount St. Helens. Each event refined preparedness and public messaging, laying foundations for today's response. As signals continue, the message is as clear as it is urgent. Adaptation and readiness are vital to minimizing risks, not merely awaiting disaster. Before we continue, don't forget to subscribe to our channel if you haven't already. Tap the bell to get instant alerts, and let us know in the comments where you're watching from. Are you close to one of these volcanoes, or following events from afar? Your stories and insights help keep us all safer and better informed. Night descends on America's restless volcanoes. Their profiles stand stark against the sky, reminders of ancient forces and enduring mystery. Scientists remain vigilant, scanning data for the next signal: a new earthquake, a spike in gas, a hint of subtle surface change. Never before have so many major U.S. volcanoes registered such notable activity within so short a window, though eruption is not yet certain at any site. Every data point, every tremor or plume, is a call for science and public attention. For all our advanced research, Earth's inner workings remain partly veiled. For those in the path of potential hazards, the next steps are clear. Maintain vigilance, stay informed, and maintain practical readiness. As communities wait, plan, and consider their own preparations, more questions surface. Will the signals subside, or will one of these volcanoes erupt and set off a cascading sequence of events? How effective are today's readiness plans, and where must they adapt to meet new challenges? We can't say with certainty when or if the next major eruption will occur, but as long as monitoring and communication continue, preparedness remains our most important safeguard. Subscribe now for updates and share your thoughts or experiences in the comments. Has your community been affected by past eruptions, or are you preparing for the possibility now? We want to hear your stories and strategies for resilience, because in times like these, shared knowledge and readiness are our greatest strengths. Stay tuned for ongoing coverage, the latest scientific insights, and expert advice as we navigate a world shaped by powerful and unpredictable forces.